Somewhere beneath the Arabian Sea, off the western coast of India, there is a city that should not exist. It rests under roughly 40 feet of salt water, buried in silt and silence, sprawling across an area so vast that the first researchers who glimpsed its outlines on sonar refused to believe what the instruments were telling them. Stone walls, paved pathways, what appeared to be the foundations of temples and markets, all of it submerged, all of it forgotten, all of it older than any comfortable timeline allows. The ocean had swallowed an entire civilization, and for thousands of years, nobody knew it was there. That city is Dwarka, and the story of its discovery, its implications, and the mysteries it still guards beneath the waves is one of the most quietly disturbing chapters in the history of underwater archaeology. It is disturbing not because of what was found, but because of what the finding suggests about how much we have lost. How many cities, how many cultures, how many chapters of human achievement now sit beneath the waterline of a planet that is 71% ocean? We map the surfaces of distant moons with greater precision than we map our own seafloor. We send instruments to photograph the rings of Saturn, yet the stone walls resting beneath the shallow waters of the Gulf of Kutch went unnoticed until the late 20th century. Consider the numbers for a moment. According to scientific estimates, roughly 95% of the world's ocean floor remains unexplored, not simply unvisited, unexplored, unmapped in any meaningful detail. The sonar resolution we have for most of the deep ocean is lower than the resolution we have for the surface of Mars. And within that vast unknown, within those millions upon millions of square miles of darkness and pressure and salt, there could be dozens of Dwarkas, hundreds. We simply do not know. Every few years, a side-scan sonar survey or a routine dredging operation reveals something that forces a revision of what we thought we understood about the human past and the shifting geography of coastlines. And every time it happens, the same uncomfortable question surfaces. What else is down there? The ancient texts of India speak of Dwarka with a reverence that borders on obsession. They describe it as a golden city, a city of unimaginable wealth and sophistication, a city built on an island in the sea by divine instruction, and a city that was ultimately reclaimed by the ocean after a great catastrophe. For centuries, scholars treated these descriptions the way scholars often treat ancient accounts of magnificent lost places. They called them myth, they called them allegory, they called them the poetic exaggerations of a culture that loved its legends. And then, in the late 1970s, an archaeologist named S.R. Rao began diving in the waters off the modern town of Dwarka in Gujarat, India, and what he found on the seabed made the myths fall silent, because there, beneath the gentle waves, were the remains of something unmistakably real. The structures extended for hundreds of meters in multiple directions. There were stone anchors of a type used in ancient maritime trade. There were semicircular bastions, the kind used in fortification walls. There were what appeared to be jetties, wharves, and the remnants of a planned urban layout. This was not a random scattering of rocks that happened to look architectural. This was a city, drowned, eroded, colonized by marine life, but a city nonetheless. And its discovery set off a chain reaction of questions that has not stopped since. How old is it, truly? Who built it? And with what level of engineering knowledge? Why did the ocean take it? And perhaps most troubling of all, why did it take modern science so long to look? The modern town of Dwarka, which stands above the waves today, is itself one of the most sacred places in all of Hindu tradition. Pilgrims have travelled there for centuries, praying at the Dwarkadish temple, walking the ghats that lead down to the sea, gazing out over the water where, according to tradition, the ancient city lies. They always believed. The archaeologists were the ones who doubted, and the ocean, indifferent to both faith and doubt, simply held the evidence and waited for someone to come looking. By the end of tonight, you are going to understand why the submerged ruins of Dwarka represent far more than an archaeological curiosity. You are going to understand how the discovery of this drowned city challenges comfortable assumptions about the ancient world, about the stability of coastlines, about the sophistication of civilizations that left no written records we can easily read, and about the sheer volume of human history that now lies beneath the waves, silent and dissolving. You are going to understand why some researchers believe Dwarka is merely the beginning, a single data point in what may be a global pattern of coastal civilizations lost to rising seas and tectonic shifts. And you are going to understand why the ocean, the largest and least understood feature of this planet, may be the greatest archive of lost human achievement that exists anywhere. Before we get started, if you find these mysteries as fascinating as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let us begin. To understand what lies beneath the waters off Gujarat, it is first necessary to understand the ocean itself. Not as a backdrop, not as a setting for adventure stories, but as a physical force, a crushing, lightless, corrosive environment that destroys almost everything it touches, given enough time. The ocean is not a passive body of water. It is an active agent of erasure, and the fact that anything survived on the seabed off Dwarka, that stone walls and anchors and foundations endured centuries or millennia of submersion, tells us something profound about the scale of what was originally built there. The world's oceans cover approximately 361 million square kilometers. That is roughly 71% of the planet's surface. The average depth of the ocean is about 3,688 meters, which is over 12,000 feet. To put that in perspective, if you took Mount Everest, the tallest point on land, at 8,848 meters, and dropped it into the Mariana Trench, the deepest point in the ocean at roughly 10,994 meters, the peak of Everest would still be submerged by more than 2,000 meters of water. The ocean is not simply large, it is incomprehensibly large. It contains an estimated 1.335 billion cubic kilometers of water. That number resists intuition. The human mind was not built to process volumes on that scale. Now consider what happens to objects placed in this environment. Salt water is one of the most corrosive natural substances on Earth. It attacks metals through electrochemical reactions. It erodes stone through a combination of chemical dissolution and physical abrasion from wave action and suspended sediment. It supports biological communities, barnacles, corals, boring organisms, algae, that physically colonize and break down submerged structures. A steel ship can be reduced to an unrecognizable ruin within a century. A wooden vessel can disappear within decades. Even stone, the most durable building material of the ancient world, is not immune. Limestone dissolves in the slightly acidic chemistry of seawater. Sandstone crumbles under the relentless grinding of suspended particles. Granite, though more resistant, is slowly worn by the endless motion of water and sand. Every surface in the ocean is under siege, always. This is the environment in which the ruins of Dwarka have persisted. The waters off the coast of Gujarat are relatively shallow, generally between 15 and 40 meters, deep in the area where the submerged structures have been found. But shallow water brings its own destruction. Tidal currents are stronger near the shore. Wave energy is more concentrated. Storms regularly churn the seabed, shifting sediment, exposing and reburying objects in unpredictable cycles. The Gulf of Kutch, the body of water adjacent to the Dwarka site, experiences some of the most extreme tidal ranges on the Indian subcontinent. The difference between high tide and low tide can exceed 5 meters in some areas. This means that twice a day, every day, for however many centuries the ruins have been submerged, the seabed has been subjected to enormous hydrodynamic forces. The fact that identifiable structures remain is, in itself, a testament to the original quality of construction. Let us establish the geography more precisely. The modern town of Dwarka sits on the western tip of the Saurashtra Peninsula in the state of Gujarat, India. It faces the Arabian Sea to the west and the Gulf of Kutch to the north. The Gomti River empties into the sea near the town, and it is in the vicinity of this river mouth, and along the coastline, extending in both directions, that the submerged ruins have been identified. The site is not a single structure or a single location. Multiple areas of underwater remains have been documented, suggesting that the ancient settlement was either very large or that multiple phases of construction and submergence occurred over time. Some researchers have identified as many as 6 distinct sectors of submerged remains, scattered across a stretch of coastline that runs for several kilometers. The first systematic underwater investigation of the site was led by Dr. S.R. Rao of the Marine Archaeology Center of the National Institute of Oceanography in Goa. Beginning in 1979 and continuing through the 1980s and into the 1990s, Rao and his team conducted a series of diving expeditions in the waters directly off the modern Dwarkadish temple, one of the most sacred pilgrimage sites in Hinduism. What they found exceeded expectations. The team identified what they described as a fortified city with massive stone walls, bastions arranged in a semicircular pattern, and a well-planned layout suggesting deliberate urban design. They recovered stone anchors, some of them of substantial size, indicating that the site had functioned as a port. They found pottery, beads, and other artifacts that they dated through various methods to different periods, some as recent as the medieval era, some potentially much older. To appreciate the significance of these finds, one must understand the role Dwarka plays in Indian tradition. In the great Indian texts, particularly the Mahabharata, Dwarka is described as the kingdom of Lord Krishna, one of the most revered figures in Hindu tradition. According to these texts, Krishna established Dwarka as a magnificent island city after leaving the city of Mathura. The descriptions are elaborate. The city is said to have had 900,000 palaces, gardens, assembly halls, and was adorned with gold, silver, and precious gems. The streets were wide and planned. The city was surrounded by a moat and protected by fortifications of great strength. And, critically, the texts state that after Krishna departed the earthly realm, the ocean rose and consumed Dwarka entirely, returning the city to the sea from which it had been carved. For centuries, mainstream archaeology treated this narrative as purely mythological. The idea that a literal city matching these descriptions had once existed and been swallowed by the sea was considered fanciful. But then the underwater surveys began returning data. And while no one has found 900,000 golden palaces on the seabed, the presence of a substantial, well-fortified, clearly planned urban settlement in precisely the location described by the ancient texts created a problem that could not be easily dismissed. Something real lay beneath those waves. The question was how to reconcile the archaeological evidence with the literary tradition, and how to date the remains with any degree of confidence. Dating submerged archaeological sites is one of the most challenging tasks in the field. On land, archaeologists rely on stratigraphy, the layered sequence of soil and debris that builds up over time. Each layer provides context for the artifacts found within it. Underwater, this orderly sequence is routinely disrupted. Currents move artifacts from their original positions. Sediment is deposited and removed by tidal action. Marine organisms bore into and encrust surfaces, making it difficult to distinguish original construction from later biological accumulation. Carbon dating requires organic material, and organic material degrades rapidly in salt water. Thermoluminescence dating, which measures the last time certain minerals were heated, can be applied to pottery, but requires careful handling of samples that is enormously complicated by the marine environment. And even when dates are obtained, they tell you when a particular artifact was made, not necessarily when it was placed at the site or when the site was submerged. The gap between creation and deposition can span centuries. Dr. Rao and his team used a combination of methods. They dated pottery fragments using thermoluminescence. They analyzed the typology of stone anchors, comparing them to anchors of known age from other sites around the Indian Ocean littoral. They examined the architectural style of the fortification walls and compared them to land-based structures of known periods across the Indian subcontinent. Their conclusions placed the main phase of the settlement somewhere in the range of the 15th to 16th century, before the Common Era, with some elements potentially older. Other researchers have proposed different dates, some more recent, some significantly more ancient. The debate over the true age of submerged Dwarka remains one of the most contested questions in Indian archaeology, and it shows no signs of resolution. But the dating controversy, intense as it is, sometimes obscures a more fundamental point. Regardless of whether the submerged structures are 3,000 years old, or 5,000 years old, or older still, the fact remains that a substantial urban settlement now lies beneath the Arabian Sea, a settlement that was once above water, a settlement that was once home to people who built walls and docks and conducted maritime trade. The ocean took it, and the ocean, in its slow, relentless way, has been dissolving it ever since. The physics of submergence is worth understanding in some detail because it tells us something important about the timeline of loss. Sea levels are not static. They never have been. According to scientific estimates derived from ice core data, coral reef analysis, and sediment records, global sea levels have fluctuated dramatically over the past several tens of thousands of years. During the last glacial maximum, roughly 20,000 years ago, according to current geological models, sea levels were approximately 120 to 130 meters lower than they are today. That is an almost incomprehensible amount of additional land that was once exposed and is now underwater. Entire continental shelves that are today covered by ocean were once dry plains, river valleys, and potentially habitable land. The coastlines of the ancient world looked nothing like the coastlines we see on modern maps. India, in particular, had a significantly larger landmass during periods of lower sea level. The western coast of Gujarat extended much farther into what is now the Arabian Sea, and the Gulf of Kutch was likely a broad, shallow embayment, or perhaps partially dry land. As the ice sheets melted, a process that accelerated significantly beginning around 15,000 to 10,000 years ago, according to geological estimates, sea levels rose. Not smoothly, not uniformly, in pulses. There were periods of rapid rise, sometimes called meltwater pulses, during which sea levels may have increased by several meters within a few centuries. Any coastal settlement that existed during such a period would have been progressively inundated. First, the lowest areas would flood, then the streets, then the walls, then the rooftops, and finally the ocean would close over everything, and the city would become a reef, a ruin, a ghost beneath the waves. The process would not have been instantaneous. It would have taken generations, long enough for people to notice, long enough for people to remember. This is the process that many researchers believe explains the submergence of Dwarka, though the specifics are debated. Some argue that post-glacial sea level rise was the primary mechanism. Others point to local tectonic activity, as the Gujarat coast is seismically active. The devastating earthquake that struck Bhuj in 2001, killing an estimated 20,000 people, was a stark reminder that this region sits atop a geologically restless landscape. The earthquake measured approximately 6.9 on the Richter scale and caused widespread destruction across the Kutch district. It demonstrated that the forces capable of raising and lowering the land in this region are not historical curiosities. They are ongoing. Land subsidence, where the ground literally sinks, whether due to tectonic forces, sediment compaction, or groundwater withdrawal, could also contribute to submergence. Most likely, a combination of factors was responsible. Rising seas, shifting tectonic plates, and the natural evolution of river channels and coastal sediment all conspired over centuries to pull Dwarka beneath the surface. The pressure at even these relatively shallow depths is worth noting. At 40 meters, the pressure exerted on a submerged object is roughly 5 atmospheres, which means every square centimeter of surface area bears a force equivalent to approximately 5 kilograms. That is like stacking 5 small cars on every square meter of wall surface. It may not sound extreme compared to the abyssal pressures of the deep ocean, where pressures can exceed 1,000 atmospheres, but it is sufficient to make diving operations difficult, to compress air spaces in the lungs and equipment of divers, and to ensure that any structural weakness in a submerged wall or foundation is ruthlessly exploited over time. Water finds every crack. Water widens every crack. Water never stops. It is the most patient destroyer on Earth. Consider the scale comparisons that make this tangible. If you stood the Great Pyramid of Giza, which rises approximately 139 meters above the desert floor, next to the depth of the ocean at the Dwarka site, the pyramid would tower over the water column by a factor of roughly 3 to 1. The ruins are not deep by oceanic standards, but they are deep enough to be invisible from the surface. deep enough to resist casual discovery for millennia, and deep enough to create serious logistical challenges for any archaeological team attempting systematic excavation. Imagine a construction worker being told to carefully excavate a buried foundation, but doing it while floating in murky water, wearing heavy equipment, breathing compressed air, fighting a current that pushes you sideways, and knowing that your time on the bottom is limited by the physics of decompression. This is what underwater archaeology looks like at Dwarka. A task that would take an hour on land can take days underwater. A site that could be mapped in a week on dry ground might take years to survey beneath the waves. Here is another comparison to grasp the enormity. The time it takes for sunlight to vanish as you descend through ocean water is shockingly short. In clear tropical waters, the top 200 meters are called the photic zone, where enough light penetrates for photosynthesis. But in the turbid, sediment-laden waters off Gujarat, effective light penetration is dramatically reduced. At just 10 to 15 meters, visibility can drop to less than a meter during certain seasons. At the depth of the Dwarka ruins, divers often work in conditions resembling a thick fog, navigating by touch and by the narrow beam of their dive lights. Imagine trying to study a wall painting in a room so dark that you can only see a circle the size of your hand at any given moment. Now imagine that the room is underwater, the floor is unstable, and a clock is ticking on your air supply. That is Dwarka. The expeditions to Dwarka have spanned decades and involved multiple institutions. After Dr. Rao's pioneering work in the 1980s, subsequent investigations were conducted by the National Institute of Oceanography and other organizations, including the Archaeological Survey of India. In 2001, a team using side-scan sonar and sub-bottom profilers surveyed the seabed off the coast of Dwarka and identified additional structural remains. These included what appeared to be a large wall running roughly parallel to the modern shoreline, extending for a considerable distance. The wall showed characteristics consistent with deliberate construction, including uniform width, consistent orientation, and the presence of what looked like regularly spaced bastions or buttresses. The sonar images were striking. Even through the distortion and noise inherent in acoustic imaging of the seafloor, the geometric patterns were unmistakable. Nature does not build in straight lines that extend for hundreds of meters. Nature does not space buttresses at regular intervals. Nature does not create perpendicular intersections between walls of uniform width. Whatever was on that seabed, it was not natural. Additional finds over the years included fragments of what researchers identified as a large stone jetty or breakwater, suggesting that the ancient settlement had significant port facilities. This is consistent with the literary descriptions of Dwarka as a major center of maritime trade. The ancient texts describe the Arabian Sea is not the only body of water guarding its secrets. Submerged structures have been reported at multiple locations along the Indian coast. In the Gulf of Cambay, also known as the Gulf of Cambat, sonar surveys conducted in 2001 detected what appeared to be geometric structures on the seabed at a depth of roughly 30 to 40 meters. In the waters off the coast of Tamil Nadu, unusual stone formations have been reported near Mahabalipuram, where local fishermen have long told stories of temples swallowed by the sea. The Bay of Bengal, the Andaman Sea, the Laccadive Sea, all of these waters wash over continental shelf areas that were once dry land. All of them could conceivably conceal evidence of ancient human activity. The question is not whether more submerged sites exist. The question is how many and how significant. What we know for certain is this. The coastlines of the world have changed. The oceans have risen. Land that was once inhabited is now submerged. And the technology to systematically search for and document what lies beneath the shallow coastal waters of the planet is only now beginning to mature. We are, in a very real sense, at the beginning of a new era of discovery, and Dwarka, the drowned city off the coast of Gujarat, is both a landmark achievement and a warning. It tells us that the ancient world was richer, more complex, and more connected to the sea than we previously understood. And it tells us that the ocean, the great destroyer and the great preserver, has more to reveal than we have yet imagined. The sheer logistical difficulty of underwater archaeology deserves further emphasis because it is central to understanding why Dwarka remains so poorly documented despite decades of attention. On land, a team of trained excavators can work an 8-hour day, moving systematically through layers of soil, recording everything they find with hand tools, photographs, and written notes. They can return to the same spot the next day and find it exactly as they left it. They can bring heavy equipment to the site. They can run electricity for lighting and computers. They can work in rain, in heat, in cold, adjusting their schedule to the weather, but never fundamentally limited by it. Underwater, none of these conditions apply. A diver working at 40 meters depth, the approximate depth of the Dwarka ruins, has a limited time on the bottom before the physics of dissolved nitrogen in the bloodstream require decompression stops on the way back to the surface. The deeper the dive and the longer the bottom time, the more extensive the decompression required. A 1-hour dive at 40 meters can require 30 to 45 minutes of decompression stops, during which the diver hangs motionless in the water column, breathing carefully, waiting for the nitrogen to off-gas from their tissues. If the decompression is rushed or skipped, the result can be decompression sickness, a painful and potentially fatal condition caused by nitrogen bubbles forming in the blood and joints. Every minute on the bottom is precious. Every minute is paid for in surface time, in air consumption, in physical exhaustion. Visibility is another constant adversary. The waters off Gujarat are not the crystal-clear tropical waters of the Caribbean or the Red Sea. They are turbid, loaded with sediment carried by rivers and stirred up by tidal currents. During the monsoon season, which runs roughly from June through September, the waters become almost opaque. Even during the best conditions in the calm months of winter, visibility at the Dwarka site can be limited to a few meters. Imagine trying to photograph a wall when you can only see 2 meters of it at a time. Imagine trying to map a city block when the far end disappears into a brown haze before you can reach it. This is the reality of working at Dwarka. Current is a third challenge. The Gulf of Kutch has strong tidal currents that can make it dangerous for divers to work during certain phases of the tidal cycle. Slack water, the brief period between tidal flows when the current is minimal, provides the best working conditions. But slack water may last only 30 to 60 minutes at a time. Outside that window, the current can push a diver off the site entirely, creating safety risks and making precise work impossible. These constraints explain why, after nearly half a century of investigation, we still do not have a complete map of the submerged settlement. The work proceeds in small increments, measured in hours of bottom time rather than days of excavation. Each season adds a piece to the puzzle, but the puzzle is enormous and the pieces are small. The researchers who have devoted their careers to this site deserve immense respect for what they have accomplished under these conditions. But they would be the first to tell you that what has been documented so far represents only a fraction of what is there. The broader context of Indian maritime history adds another layer of significance. India's relationship with the sea is ancient and deep. The Indus Valley Civilization, which preceded and may have overlapped with the settlement at Dwarka, maintained active maritime trade. Harappan seals have been found at sites in Mesopotamia, and Mesopotamian artifacts have been found at Harappan sites, indicating sustained commercial contact across the Arabian Sea. The ancient Indian text, known as the Artha Shastra, attributed to the scholar Kautilya, contains detailed instructions for managing ports, ships, and maritime trade, suggesting a sophisticated understanding of naval administration. The Periplus of the Erythraean Sea, a Greek-Egyptian text from the 1st century of the Common Era, describes the ports of western India in considerable detail, naming specific harbours, listing trade goods, and noting the seasonal patterns of monsoon-driven shipping. India was not a landlocked civilization that happened to have a coast. It was a maritime civilization from deep in its past, and Dwarka, positioned at the western extremity of the Indian subcontinent, at the mouth of the Gulf of Kutch, would have been ideally situated to serve as a gateway for trade between India and the wider Indian Ocean world. The stone anchors found at the Dwarka site reinforce this maritime interpretation. More than 50 stone anchors have been documented at the site, making it one of the densest concentrations of ancient anchors found anywhere in the Indian Ocean region. The anchors vary in size and design, suggesting use over a long period and by vessels of different types and sizes. Some are of the simple grapnel type, suitable for small boats in shallow water. Others are large composite anchors with multiple holes for flukes and ropes, designed for larger vessels operating in deeper water and stronger currents. The variety tells a story of a port that served many kinds of traffic, from local fishing boats to long-distance merchant vessels. What we know for certain is this: the coastlines of the world have changed, the oceans have risen, land that was once inhabited is now submerged, and the technology to systematically search for and document what lies beneath the shallow coastal waters of the planet is only now beginning to mature. We are at the beginning of a new era of discovery, and Dwarka is both a landmark achievement and a warning. It tells us that the ancient world was richer, more complex, and more connected to the sea than we previously understood. And it tells us that the ocean has more to reveal than we have yet imagined. What scientists discovered next was worse than anyone expected. The core problem with Dwarka is not that it exists. Submerged settlements are known from many parts of the world. The Mediterranean has dozens. The Black Sea has yielded several. The coastlines of northern Europe, particularly around the British Isles, conceal the remains of communities that were flooded as Ice Age glaciers released their meltwater. What makes Dwarka different, what makes it a problem, is the collision between its physical reality and the narrative tradition that surrounds it. Because the ancient Indian texts do not merely mention Dwarka in passing, they describe it with a specificity that is unusual for mythological accounts. They name its streets, they describe its defences, they enumerate its gates, and the archaeological evidence, while incomplete, aligns with those descriptions in ways that are difficult to dismiss as coincidence. The Mahabharata, one of the two great Indian literary works, provides the most detailed account of Dwarka. This text, which scholars believe was composed and revised over many centuries, describes the city as being located on an island, protected from the sea by massive walls. It describes planned streets, residential quarters, public buildings, markets, and a harbour. It describes the city as a centre of governance and trade, visited by dignitaries and merchants from distant lands. And it describes, with a kind of mournful precision, the end of the city. After the departure of Krishna, the text states, the sea began to rise. The waters advanced upon the city. The inhabitants fled inland, carrying what they could. And then the ocean closed over Dwarka, and the city was gone. The Harivamsa, an appendix to the Mahabharata, and several of the Puranas, another category of ancient Indian text, provide additional details. They describe the city as having been surrounded by a defensive moat. They describe multiple levels of fortification. They describe a city that was not merely functional, but beautiful. A city designed to inspire awe. For generations, scholars placed this narrative firmly in the category of legend, and there were good reasons for that caution. The Mahabharata is a complex literary work, composed and revised over many centuries, blending historical memory with theological reflection, moral instruction, and pure imagination. It contains episodes involving divine weapons capable of destroying entire armies, flying chariots, and battles that last for days. Separating factual kernels from literary embellishment in such a text is extraordinarily difficult. Many scholars argued, reasonably, that the Dwarka of the Mahabharata was a symbolic place, a representation of impermanence and divine order, not a literal city that could be located on a map. The description of golden palaces and unimaginable wealth was, in this view, poetic hyperbole, a literary device, rather than a factual claim. And then the divers went down, and the walls were there. Dr. S.R. Rao's initial findings in the 1980s created a stir, but it was a stir largely confined to specialists. Indian archaeology, particularly maritime archaeology, did not command the same international attention as the excavation of Troy or the discovery of Tutankhamun's tomb. The methods available were limited. Rao and his team worked with basic diving equipment, limited bottom time, and poor visibility. They had no multi-beam sonar, no remotely operated vehicles, no GPS-guided positioning systems. They had air tanks, measuring tapes, and cameras in waterproof housings. And yet, with these rudimentary tools, they mapped a site of extraordinary importance. Among those who understood the significance, the implications were profound. Here was a text that described a city in a specific location, a city swallowed by the sea, and here was physical evidence of a substantial urban settlement at precisely that location beneath the sea. The correlation was uncomfortable for those who preferred to maintain a clean separation between mythology and archaeology, between sacred texts and empirical data. The problem deepened with each subsequent expedition. In the 1990s, further diving operations revealed additional structural elements. Researchers identified what they described as a large, roughly rectangular structure that they interpreted as a possible citadel or fortified enclosure. Its dimensions were substantial, extending over a significant area of the seabed. The walls appeared to be constructed from dressed stone blocks, fitted together without mortar, a technique consistent with ancient Indian construction practices, known from land-based sites across the subcontinent. Near this structure, the team found concentrations of stone anchors, reinforcing the interpretation of the site as a port city. They also recovered fragments of pottery that showed similarities to known ceramic traditions of the Indian Bronze Age. The stone anchors themselves became a subject of intense study. Anchors are among the most durable artifacts of maritime cultures. Made of heavy, dense stone, they resist corrosion and biological degradation better than most other ancient objects. The anchors found at Dwarka were of several types. Some were simple triangular or trapezoidal stones with a single hole drilled near the top. Others had 3 holes, 2 at the base for securing wooden flukes, and 1 at the top for the anchor rope, representing a more advanced and effective design. Researchers compared them to anchors found at other ancient port sites around the Indian Ocean, including sites along the coast of Oman, in the Persian Gulf, and at ports in the Red Sea. They found typological similarities that suggested shared maritime traditions or direct trade connections. This was significant. It meant Dwarka was not an isolated coastal settlement. It was potentially a node in a network of maritime exchange that connected the Indian subcontinent to the Arabian Peninsula, East Africa, and the wider Indian Ocean world. But here is where the core problem becomes acute: the dating. Every attempt to establish a firm chronology for the submerged remains has produced contested results. Dr. Rao, based on the typology of the anchors, the style of the fortification walls, and the thermoluminescence dates obtained from pottery fragments, proposed that the main phase of the city dated to the 2nd millennium before the Common Era, roughly the 16th to 15th century before that era. This would place it within the later stages of what archaeologists call the Harappan or Indus Valley civilization, one of the great urban cultures of the ancient world. The Harappan connection is tantalizing. The Indus Valley civilization, which flourished in what is now Pakistan and northwestern India, was characterized by remarkable urban planning. Its cities, Mohenjo-Daro and Harappa, being the most famous, featured grid-pattern streets, sophisticated drainage systems, standardized brick sizes, and public buildings of impressive scale. The civilization extended over an area of roughly 1 million square kilometers, making it one of the largest of the ancient world. It maintained trade connections with Mesopotamia, as evidenced by Harappan seals found at Sumerian sites and Mesopotamian artifacts found at Harappan sites. If Dwarka was a Harappan or post-Harappan settlement, it would represent a significant extension of that civilization's reach, demonstrating that its urban planning traditions were carried westward to the Gujarat coast and adapted for a maritime setting. Some researchers have argued exactly this, pointing to similarities in construction techniques, in artifact types, and in the overall ethos of careful urban planning. Other researchers disagree. Some have proposed later dates for the submerged structures, placing them in the 1st millennium before the Common Era, during the period of historical Dwarka that is attested in other archaeological and literary sources. The city of Dwarka has a long and layered history. The modern town and the seabed beneath the adjacent waters contain archaeological remains from multiple periods, including what appears to be a medieval port, an early historical settlement, and the more enigmatic deeper layers that resist easy dating. It is possible, some argue, that the submerged structures represent not a single ancient city, but a series of settlements built, abandoned, and rebuilt over thousands of years, with the oldest phases now buried beneath layers of marine sediment beyond the reach of current investigation techniques. And it gets worse, because the controversy over Dwarka is not merely a technical debate about pottery typology and radiocarbon calibration curves. It is entangled with questions of national identity, religious belief, and the politics of heritage. Dwarka is one of the Char Dham, the 4 sacred pilgrimage sites of Hinduism. It is a place of immense spiritual significance to hundreds of millions of people. The suggestion that the underwater ruins might be the literal remains of the city described in the Mahabharata carries enormous emotional and cultural weight. For some, the archaeological evidence is confirmation that the ancient texts are historically accurate, that the events described in the Mahabharata are real events, and that the history of Indian civilization extends much further back in time than many scholars have traditionally acknowledged. For others, particularly those committed to secular, evidence-based archaeology, the danger lies in allowing religious conviction to drive interpretation of ambiguous physical evidence. The space between these positions is narrow, and the passions on both sides are intense. This tension is not unique to Dwarka. It is present wherever archaeology intersects with sacred narrative. The excavation of Troy by Heinrich Schliemann in the 1870s raised similar questions. Was Homer's Troy a real place? The discovery of a multi-layered settlement at Hisarlik in modern Turkey suggested that it was, or at least that it could be. But identifying which layer corresponded to the Troy of the Iliad and determining how much of Homer's narrative reflected historical events proved maddeningly difficult. Scholars have debated the matter for a century and a half, and no consensus has emerged. The same kind of interpretive challenge faces anyone who attempts to connect the underwater ruins of Dwarka with the golden city of the Mahabharata. The material evidence can anchor the discussion. It can confirm that a city existed, but it cannot bridge the full distance between stone walls and sacred stories. The physical evidence can tell us that a settlement existed. It can tell us roughly how large it was. It can give us clues about when it was active and what its inhabitants did, but it cannot tell us who they worshipped, what stories they told, or whether a specific figure from a specific text walked its streets. That gap between material evidence and narrative meaning is the core problem of Dwarka. It is a gap that cannot be closed by more diving, more sonar, or more radiocarbon dates. It can only be navigated by a disciplined willingness to hold multiple possibilities in mind simultaneously, to acknowledge what we know, what we suspect, and what we do not know, without collapsing those 3 categories into one. One of the most significant expeditions to the Dwarka site took place in 2007, when a joint team from the National Institute of Oceanography and the Archaeological Survey of India conducted an extensive underwater survey using updated technology. This team used multi-beam sonar, sub-bottom profilers, and GPS-guided diving to create a more detailed map of the submerged structures than had previously been possible. Their results confirmed many of Rao's original findings and added new details. They identified additional wall segments, some extending into areas that had not been previously surveyed. They documented what appeared to be a large stone-lined channel or canal, which some researchers interpreted as part of the city's water management infrastructure. The canal, if that is what it is, ran between structures in a manner consistent with planned drainage or water supply. The canal interpretation, if correct, is enormously significant. Water management, the ability to channel, store, and distribute fresh water, is one of the hallmarks of advanced urban civilization. The Harappan cities are famous for their drainage systems. Roman cities are remembered for their aqueducts. If the submerged city at Dwarka possessed a canal system, it would indicate a level of engineering sophistication consistent with a major urban centre, not a small fishing village or temporary encampment. It would suggest a community that had the organizational capacity to plan, build, and maintain complex infrastructure. It would suggest a community with a surplus of labor, with specialized skills, with a governing structure capable of coordinating large-scale public works. The comparison with Lothal, the Harappan port city located approximately 300 kilometers south of Dwarka in the same Gujarat region, is instructive. Lothal was excavated on land by the Archaeological Survey of India beginning in 1954, and its discoveries revolutionized the understanding of Harappan maritime capability. The site contained what many archaeologists interpret as a tidal dockyard, a trapezoidal basin lined with kiln-fired bricks, measuring approximately 219 meters by 37 meters. If this interpretation is correct, it was one of the earliest known artificial docks in the world. The basin was connected to the river and the sea by channels, and its construction demonstrated an understanding of tidal patterns, water management, and maritime engineering that was far more sophisticated than previously attributed to the Harappan civilization. Lothal also yielded a remarkable assemblage of artifacts, including a bead factory, a coppersmith's workshop, Mesopotamian-style cylinder seals, and a device that some researchers have interpreted as a navigational instrument. Lothal was not an anomaly. It was a window into a maritime world that the Harappan civilization had created along the Gujarat coast, a world that was almost entirely invisible to land-based archaeology because so much of it now lies beneath the water. Dwarka, viewed in this context, becomes not an isolated curiosity, but a piece of a larger puzzle. The Gujarat coast, with its deep harbours, its tidal estuaries, its proximity to both the Arabian sea trade routes and the resource-rich interior of the Indian subcontinent, was ideally positioned for maritime commerce. If Lothal was one node in a network of Harappan port cities, then Dwarka may have been another. And if there were two, there may have been more, some of which are now submerged, undiscovered, and disintegrating on the continental shelf. This possibility takes on additional weight when you consider the broader context of Indian Ocean trade in antiquity. The monsoon winds of the Indian Ocean create a natural cycle of trade. From roughly April to September, the southwest monsoon blows from Africa toward India, filling the sails of ships bound eastward. From October to March, the northeast monsoon reverses the pattern, carrying ships back westward. This predictable oscillation made the Indian Ocean the world's first great maritime highway. By the time of the Roman Empire, Pliny the Elder was complaining about the drain of Roman gold to India in exchange for spices, textiles, and gemstones. But this trade did not spring into existence fully formed in the classical period. It had deep roots. How deep precisely is the question. The anchors at Dwarka, the dock at Lothal, the Mesopotamian seals found at Harappan sites, all of these suggest that organized maritime trade in the Indian Ocean was already well established by the 2nd or 3rd millennium before the Common Era. Dwarka, sitting at the western tip of the Saurashtra Peninsula like a sentinel overlooking the approaches to the Gulf of Kutch, would have been perfectly positioned to participate in, and perhaps control a significant portion of this traffic. The team also recovered additional artifacts during the 2007 expedition and subsequent surveys: copper fishhooks, iron nails, fragments of what appeared to be a large storage vessel, possibly used for grain or liquid, and, perhaps most intriguingly, several pieces of carved stone that bore decorative motifs. These motifs, while difficult to analyze in their eroded condition, showed similarities to decorative traditions known from other ancient Indian sites. They suggested a culture with aesthetic sensibilities, with craft traditions, with the surplus of time and resources necessary to produce objects that served no strictly utilitarian purpose. A culture that carved beauty into stone, even knowing that the stone would face the sea. There is a concept in archaeology called taphonomy, the study of how organisms and artifacts decay, transform, and become part of the geological record after death or deposition. Taphonomy is the science of loss. It studies what survives and why. In the context of Dwarka, the taphonomic processes are relentless. Stone dissolves, metal corrodes, wood vanishes within years. Organic materials, textiles, food remains, human bone, are consumed by marine organisms within months. What remains is the most durable fraction of what was once a living city. The stone foundations, the heaviest artifacts, the outlines of the largest structures. Everything else is gone. The people who lived there, the goods they traded, the languages they spoke, the songs they sang at the harbour, all of it has been absorbed by the sea. We are studying a skeleton, And from that skeleton, we are trying to reconstruct a living, breathing city. The challenge is humbling. The impossibility of full recovery is absolute. Consider what an archaeologist working on land can learn from a well-preserved site. Post holes reveal the locations of wooden buildings. Seeds and animal bones reveal diet and farming practices. Pottery styles reveal trade connections and cultural affiliations. Written records, when they exist, reveal names, dates, transactions, beliefs. Metal tools reveal technological capacity. Textile fragments reveal craft traditions. At Dwarka, most of this information is gone. The organic remains have decomposed. Any wooden structures have vanished. If there were inscriptions on perishable materials, they are lost forever. If there were murals painted on walls, the paint has dissolved. If there were gardens, the plants are gone. We are left with stone and ceramic, the two most durable classes of artifact, and even these are in fragmentary condition. Every piece that survives is precious. Every piece that is lost is gone forever. And yet, the fragments speak. They speak of a city that was not small, not a fishing village, not a seasonal camp, a city with fortification walls thick enough to withstand siege, with planned streets wide enough for traffic, with port facilities extensive enough to accommodate multiple large vessels, with trade goods that connected it to distant markets. The fragments tell us that someone, at some point in the past, that we are still struggling to precisely define, invested enormous resources in building a major settlement at the western tip of the Indian subcontinent, in a location perfectly positioned to command maritime trade routes linking India with the Persian Gulf, the Arabian Peninsula, East Africa, and beyond. The fragments tell us that this investment was sustained over time, that the city was maintained and perhaps expanded over generations. And the fragments tell us that in the end, it was not enough. The ocean came, the city fell. The history of deep sea and underwater exploration is punctuated by moments of humbling realization. When the HMS Challenger expedition of 1872 to 1876 first systematically sampled the deep ocean floor, the scientists aboard were astonished to discover life at depths previously thought to be barren. When Robert Ballard discovered the wreck of the Titanic in 1985, using remote-operated vehicles at a depth of nearly 3,800 meters, the images shocked the world. Not because the ship was there, everyone knew roughly where it had sunk, but because of the state of preservation. The cold, dark, oxygen-poor water of the deep Atlantic had preserved details that would have vanished within years on land. China patterns were still recognizable. Shoes lay in pairs on the deck, their leather consumed but their shapes held by the sediment. The deep ocean, it turned out, was not merely a graveyard, it was a museum. Dwarka is not in the deep ocean, but it shares with those deep water sites a quality of suspended time. The salt water has corroded, the currents have shifted, the marine life has colonized, but the bones of the city are still there, the walls reduced but recognizable, the anchors scattered but identifiable, the layout obscured but traceable. Somewhere beneath the silt and the coral, the city persists, and every year, every monsoon, every tidal cycle, a little more of it dissolves. The clock is running, the evidence is disappearing, and the questions it could answer, questions about the antiquity and sophistication of coastal civilization, about maritime trade networks in the ancient world, about the relationship between mythology and historical memory, are disappearing with it. This is the Dwarka problem. It is real, it is underwater, it is eroding, and it is telling us something about the ancient world that we are only beginning to hear. The magnitude of the problem becomes clearer when we consider the regional context. Dwarka is not the only place along the Indian coast where the ocean may conceal significant archaeological remains. The entire western seaboard of India, from the tip of Gujarat in the north to the coast of Kerala in the south, runs along a continental shelf that was significantly more exposed during periods of lower sea level. Archaeological surveys on land have revealed a dense pattern of ancient settlements, ports, and trading posts along this coast, particularly during the periods of active Indian Ocean trade that linked India to Rome, to Southeast Asia, to East Africa, and to China. If the density of coastal settlement observed on the current shoreline extended to the now submerged portions of the continental shelf, the underwater archaeological potential of Western India is staggering. The port city of Lothal, a Harappan site located inland in Gujarat, provides a useful comparison. Excavated in the 1950s and 60s by S.R. Rao, the same archaeologist who later led the Dwarka underwater surveys, Lothal revealed a planned city with a remarkable feature: what appears to be a large, brick-lined tidal dock, one of the earliest known facilities for berthing and servicing ships. The dock measured approximately 218 meters long and 37 meters wide, with inlet and outlet channels that may have been designed to regulate the flow of tidal water. If a city as far inland as Lothal, located on a now silted river channel, possessed such sophisticated maritime infrastructure, what might the true coastal cities of the same era have contained? Lothal is above water because it was built far enough inland to escape submergence. The cities that were built closer to the ancient shoreline were not so fortunate. The Indian Ocean, the body of water that washes the western coast of India, has its own history as a theatre of human activity. Long before the European age of exploration, the Indian Ocean was crisscrossed by trading networks of extraordinary complexity. Arab dows, Indian merchant vessels, Chinese junks, and Austronesian outrigger canoes all plied these waters, carrying goods, people, ideas, and diseases across thousands of miles. The monsoon winds, which blow reliably from the southwest during summer and from the northeast during winter, provided a natural engine for maritime travel, enabling round-trip voyages between India and East Africa, or between India and Southeast Asia on an annual cycle. Any city positioned to take advantage of these wind patterns would have been a node of tremendous economic and cultural importance. And Dwarka, sitting at the western tip of India, where the Arabian Sea meets the Gulf of Kutch, was positioned exactly at such a node. The ancient texts seem to know this. The descriptions of Dwarka in the Mahabharata and the Harivamsa are not merely descriptions of a beautiful city. They are descriptions of a wealthy city, a connected city, a city through which the goods and peoples of distant lands flowed. Gold, silver, gems, textiles, spices, horses. The texts describe ships and trade and the bustling energy of a major commercial centre. Strip away the divine embellishments, set aside the 900,000 golden palaces, and what remains is a description that is entirely consistent with the archaeological evidence. A large, fortified port city at a strategic location on the Indian coast, engaged in long-distance maritime trade. The significance of the carved stone fragments found at the site also warrants further discussion. In ancient India, stone carving was not a casual activity. It required specialized skills, specialized tools, and a patron willing to invest resources in producing objects of beauty. The presence of carved decorative elements at a submerged site tells us that the community was not living at subsistence level. It had surplus, it had specialization, it had a social structure complex enough to support artisans who produced objects of aesthetic rather than strictly practical value. This is consistent with an urban centre, not a fishing village. Villages produce nets and hooks and clay pots. Cities produce carved stone, decorated pottery, and planned architecture. Dwarka, whatever we ultimately conclude about its date and its relationship to the literary tradition, was a city. The underwater survey, conducted by the Geological Survey of India and the National Institute of Oceanography, in collaboration during the early 2000s, added another dimension to the evidence. Using sub-bottom profiling, a technique that sends acoustic pulses into the seabed and records the echoes from buried layers, researchers detected what appeared to be buried structures beneath the current sediment surface. This is enormously significant because it means that the visible ruins, the walls and foundations that divers can see and touch, may represent only the upper layer of a much deeper and more complex site. The earliest phases of occupation, the oldest buildings, the original foundations, may be buried meters below the current seabed, sealed beneath centuries of accumulated sediment and accessible only through systematic excavation or advanced remote sensing techniques that do not yet exist in a form suitable for routine use in the challenging conditions off Gujarat. But here is what makes this truly terrifying. If Dwarka, a site that was known from ancient texts, that was located in shallow water off a major modern town, that was investigated, by trained archaeologists using increasingly sophisticated technology. If this site has still not been fully documented and understood after nearly half a century of work, then what hope do we have of finding and studying the sites we do not know about? The sites that no ancient text describes. The sites that lie in deeper water, off more remote coastlines, in regions where no one has thought to look. The sites that are dissolving right now, at this moment, as the tides wash back and forth and the sediment shifts and the ocean continues its patient, endless work of erasure. We are not losing the past in some abstract metaphorical sense. We are losing it physically, atom by atom, day by day, and we are not even looking. The story of Dwarka cannot be understood in isolation. It is one thread in a much larger tapestry of submerged mysteries that span the world's oceans. To grasp the full weight of what the Dwarka discovery implies, it is necessary to examine other underwater enigmas, other places where the ocean has swallowed evidence of human activity or geological processes that challenge our assumptions. Each of these sites illuminates a different facet of the problem. Each reveals a different limitation of our technology, our methodology, or our imagination. And taken together, they paint a portrait of a planet whose shallow coastal waters contain an archaeological record of staggering richness that we have barely begun to access. The first angle worth examining is the phenomenon of hydrothermal vents and the life that clusters around them. In 1987, scientists aboard the research submersible Alvin, diving near the Galapagos Rift at a depth of roughly 2,500 meters, discovered something that fundamentally altered our understanding of biology. They found communities of organisms, giant tube worms up to 2 meters long, clams the size of dinner plates, white crabs, and dense mats of bacteria, thriving in complete darkness, in water heated to extreme temperatures by volcanic activity on the ocean floor. These organisms were not dependent on sunlight. They were not part of the photosynthetic food chain that sustains nearly all other life on the surface. Instead, they derived their energy from chemical reactions, specifically from the oxidation of hydrogen sulfide and other chemicals released by the vents. This process, called chemosynthesis, had been theorized but never before observed sustaining an entire complex ecosystem. The water temperature at these vents can exceed 360 degrees Celsius at the point of emission, though it cools rapidly upon mixing with the surrounding near-freezing seawater. The chemical environment is toxic by any surface standard, rich in hydrogen sulfide, heavy metals, and dissolved minerals that would be lethal to most organisms. And yet, life not only survives there, but flourishes, forming some of the densest biological communities on Earth. The tube worms grow at rates that astonished the biologists who first measured them. The bacterial mats form the base of a food web that includes dozens of species, many of them found nowhere else on the planet. The relevance to Dwarka may not be immediately obvious, but the connection is fundamental. The discovery of hydrothermal vent communities proved that the ocean contained entire worlds that we had never imagined, entire ecosystems operating by rules we did not understand, in places we had never looked. If the deep ocean could conceal something as fundamental as a new mode of life for decades after we had supposedly entered the age of modern oceanography, what else was it concealing? The lesson of the hydrothermal vents was not merely about biology, it was about the limits of assumption. We assumed the deep ocean floor was a barren desert. It was not. We assumed that all complex life required sunlight. It did not. We assumed that our maps and models accurately represented the reality of the ocean floor. They did not. Apply the same logic to coastal archaeology. We assumed that the great civilizations of the ancient world were primarily inland cultures, centered on river valleys. We assumed this because those are the places where we found evidence. But what if this picture is incomplete? What if coastal civilizations were equally significant, but simply less visible? Not because they were less sophisticated, but because the ocean took them. The Dwarka discovery suggests exactly this possibility, and the hydrothermal vent analogy reminds us that our failure to find something is not evidence that it does not exist. The absence of evidence is not evidence of absence, as the old maxim states. And in the case of submerged coastal archaeology, the absence of evidence may be nothing more than the absence of effort. We have not found more Dwarkas because, by and large, We have not looked for them. The few times we have looked, we have found them. Consider the pattern. When Schliemann looked for Troy, he found it. When Rao looked for Dwarka, he found structures. When the Indian Navy conducted sonar surveys in the Gulf of Cambay, they detected geometric anomalies. When fishermen off the coast of Mahabalipuram reported underwater structures after the 2004 tsunami temporarily receded the waters, survey teams found carved stone blocks on the seabed. When divers explored the waters off the Egyptian port of Alexandria, they found the remains of the ancient city, including colossal statues and sphinxes from the legendary Pharos Lighthouse district. When Franck Godillot's team investigated the submerged Egyptian cities of Thonis Heraklion and Canopus in Abuk Bay, they found entire urban complexes, complete with temples, harbours, and monumental statuary, cities that had been lost for over 1,000 years. The pattern is consistent. Every time someone actually looks beneath the shallow coastal waters with competent equipment and trained eyes, something is found. This should tell us something. It should tell us that the ocean floor, particularly the shallow continental shelf, is not an empty desert. It is a populated landscape. We just have not bothered to survey most of it. The second angle takes us to one of the most haunting environments in the ocean: brine pools. These are bodies of water on the ocean floor that are so saturated with dissolved salt that they are significantly denser than the surrounding seawater. They form distinct pools, complete with shores and surface waves, on the seabed itself, an ocean within the ocean. The visual effect, as captured by submersible cameras, is surreal beyond description. You see a flat mirror-like surface on the bottom of the sea. You see waves rippling across it. You see a shoreline where the brine meets the normal seawater, and around the edges of these pools you see the bodies of creatures that wandered too close. Fish, eels, crabs, lying motionless in the toxic brine, pickled by the extreme salinity, preserved in death by the same chemistry that killed them. Brine pools have been found in the Gulf of Mexico, the Red Sea, the Mediterranean, and other deep basins. Some are small, mere puddles on the ocean floor. Others are vast, stretching across areas measured in hundreds of square meters. The largest known brine pools are deep, typically found at depths exceeding 500 meters, but their existence demonstrates a principle that is critical for understanding submerged archaeology. The ocean is not a uniform environment. Its conditions vary enormously from place to place, from depth to depth, from season to season, and those variations have profound effects on preservation. In the extreme chemistry of a brine pool, organic material that would be consumed by bacteria and marine organisms within weeks in normal seawater can persist for much longer periods. Wood, bone, leather, materials that vanish rapidly in typical marine conditions, can be preserved by the hostile chemistry that prevents biological degradation. No one is suggesting that the ruins of Dwarka are preserved in a brine pool. The conditions at the Dwarka site are entirely different, but the principle is illuminating. The ocean's capacity for destruction is not uniform. It is variable. It depends on local chemistry, on temperature, on the presence or absence of specific biological communities, on the nature of the sediment, on the pattern of currents. Some underwater environments are extraordinarily destructive. Others are, by comparison, gentle. The ruins at Dwarka have survived because of a particular combination of factors: the durability of stone construction, the buffering effect of overlying sediment, the relatively calm conditions at certain seasons. Other sites, in other conditions, may have survived even better, or may have been destroyed more completely. The ocean rolls the dice for every site it swallows, and we do not get to choose the outcome. The third angle involves one of the most enigmatic underwater structures ever discovered, one that shares with Dwarka the uncomfortable quality of being difficult to explain. Off the southern coast of Yonaguni Island, at the southwestern tip of Japan, there lies a massive stone formation submerged in roughly 25 meters of water. Discovered in 1986 by a local diver named Kihachiro Aratake, the Yonaguni Monument, as it has come to be known, is a terraced structure of enormous proportions. Its main feature is a roughly rectangular formation approximately 27 meters long, several stories high, with flat surfaces, right angles, and what appear to be steps, platforms, and channels shaped into the rock. The debate over the Yonaguni monument has raged for decades, and it has never been resolved. On one side are geologists like Robert Schoch, who visited the site in 1997 and concluded that many of its features could be explained by natural geological processes. Sandstone and mudstone, the rock types that compose the formation, do tend to fracture along straight lines and at right angles, producing formations that can look deceptively architectural. The layered structure of the rock, combined with the effects of marine erosion, can create step-like terraces and flat platforms without any human intervention. On the other side are researchers like Masaki Kimura of the University of the Ryukyus, who has studied the site for decades and argues that while the base rock is natural, the features show clear evidence of human modification. Kimura has identified what he interprets as a road, a gateway, a drainage channel, a carved face, and several other features that he believes cannot be explained by natural processes alone. The numbers are striking. The formation spans an area roughly 100 meters long and 50 meters wide. Its flat terraces are remarkably uniform in dimension. The angles between surfaces are consistently close to 90 degrees. Some of the step-like features have rises of uniform height across their entire length. If natural, the Yonaguni monument represents an extraordinary coincidence of geological processes producing a form that mimics human architecture with uncanny precision. If artificial, or even partially modified by human hands, it would be among the most remarkable underwater structures ever documented, potentially dating to a period when sea levels were low enough for the site to have been above water, which would push its creation back many thousands of years, according to geological sea level data. The relevance to Dwarka is twofold. First, the Yonaguni monument demonstrates how painfully difficult it is to distinguish between natural and artificial structures in the underwater environment. On land, the distinction is usually straightforward. You can see tool marks. You can identify materials that were transported from elsewhere. You can find the detritus of construction, chips, offcuts, discarded tools. Underwater, where erosion, biological colonization, and sediment obscure original surfaces, the distinction can be agonizingly ambiguous. This ambiguity haunts the study of Dwarka as well. While the main structures at Dwarka are more clearly architectural than the Yonaguni monument, with identifiable walls, anchors, and artifacts confirming human activity, there are peripheral features at the site whose interpretation remains uncertain. Are those linear features on the sonar really walls, or are they natural ridges? Is that circular formation a well, or a natural depression in the bedrock? The ocean blurs every boundary between the built and the natural. The controversy over the Yonaguni monument also illustrates a deeper problem in underwater archaeology: the difficulty of achieving scientific consensus when the primary evidence is hard to access and harder to replicate. On land, if two archaeologists disagree about the interpretation of a feature, they can both visit the site, examine it at leisure, take measurements, collect samples, and discuss their observations face to face. Underwater, site visits are expensive, physically demanding, and limited in duration. Not every researcher who has an opinion about the Yonaguni monument has actually dived on it. Not every researcher who has an opinion about Dwarka has seen the ruins firsthand. Much of the debate takes place at a remove, based on photographs, sonar images, and published reports, rather than direct observation. This introduces an additional layer of uncertainty that does not exist in terrestrial archaeology, and it makes resolving disputes correspondingly more difficult. Second, the Yonaguni monument raises the same fundamental question that Dwarka raises: the question of what lies beneath the shallow coastal waters of the world. The continental shelves, those gently sloping platforms of land that extend outward from every continent before plunging into the deep ocean, were exposed during periods of lower sea level. They were not barren wastelands. They were coastal plains, river valleys, deltas, and shorelines, exactly the kinds of environments where human communities have always tended to settle. If even a small fraction of those now submerged landscapes bore the marks of human habitation, the underwater archaeological record of the planet would be immense, staggeringly immense. And we have explored almost none of it. The fourth angle takes us into the realm of creatures that defy what we thought we knew about biology, and in doing so, remind us how much the ocean still conceals. The deep ocean harbors organisms that seem to violate the rules governing life as we understand it on the surface. Giant squid, reaching lengths of up to 13 meters or more, were the subject of myth and terror for centuries before science confirmed their existence. The first photographs of a living giant squid in its natural habitat were not taken until 2004 by a Japanese research team that spent years developing a specialized deep-sea camera system. For millennia, the largest invertebrate on Earth hid from human observation in the deep waters of the Pacific. Consider the barrel-eye fish, with its transparent head that allows its tubular eyes to rotate and look upward through its own skull. Consider the anglerfish, which carries a bioluminescent lure on a modified dorsal spine, dangling light in the eternal darkness to attract prey. Consider the organisms that live in the Hadal Zone, the deepest region of the ocean below 6,000 meters, where pressures exceed 600 atmospheres and temperatures hover just above freezing. Amphipods the size of shrimp thrive there, in conditions that would instantly kill any surface organism. Sea cucumbers crawl along the abyssal plains, processing sediment, living their entire lives in total darkness, under pressures that would crush a submarine. These creatures are relevant to the Dwarka story, not because they have anything to do with submerged cities, but because they remind us that the ocean is not an extension of the world we know. It is a different world, a parallel world, one that operates by its own rules and reveals itself only reluctantly, only to those who bring the right tools and the right questions and the patience to wait. We have been studying the ocean for centuries, and we are still being surprised by what we find. The coelacanth, a fish that was believed extinct for tens of millions of years based on the fossil record, was found alive in 1938 off the coast of South Africa. The discovery was so shocking that the scientific community initially refused to believe it. If the ocean can hide living animals of that size for that long, it can certainly hide the stone walls of a drowned city. The fifth and final angle in this exploration involves the broader question of missing ships, missing aircraft, and the ocean's capacity for total erasure. We tend to think of the ocean as a place where things are lost but potentially recoverable. The Titanic was found. The Bismarck was found. The wreck of the San Jose, a Spanish galleon that sank in 1708 off the coast of Colombia, was located in 2015 at a depth of roughly 600 meters, with its cargo of gold, silver, and emeralds reportedly still intact. These famous discoveries create the impression that the ocean keeps what it takes, that anything that sinks can eventually be found if we look hard enough. But this impression is misleading. For every wreck that has been located, there are hundreds, perhaps thousands, that have never been found and never will be. The ocean floor is vast, and the objects resting on it are small. A ship that sinks in deep water may break apart on the way down, scattering debris across a wide area. It may land on a sloping surface and slide into a submarine canyon, buried under subsequent sediment flows. It may be consumed by biological processes, its wooden hull devoured by shipworms, its metal fittings corroded to nothing. The ocean does not merely hide things, it destroys them, and the rate of destruction depends on conditions that vary from place to place and are often impossible to predict. The MH370 flight that disappeared over the Indian Ocean in 2014 remains one of the most intensive search operations in history. Despite years of effort, employing some of the most advanced deep-sea search technology available, including autonomous underwater vehicles, scanning the seabed with sonar at resolutions measured in centimeters, the main wreckage has not been found. The search area covered over 120,000 square kilometers of ocean floor, an area larger than many countries. And yet, the ocean is larger. The Indian Ocean alone covers roughly 70 million square kilometers. The search covered less than 0.2% of it. The implications for submerged archaeology are stark. If we cannot find a modern aircraft equipped with emergency locator transmitters, in an era of satellite tracking and sonar technology, in an ocean that was being searched by some of the most capable vessels on Earth, How confident can we be that we have found even a meaningful fraction of the submerged settlements that lie on the continental shelves? The answer is that we cannot be confident at all. Dwarka was found because people knew where to look. The ancient texts pointed to a specific location. The modern town of Dwarka sat atop the site. The connection between tradition and geography was preserved across centuries. But most submerged settlements do not have the luxury of a literary tradition pointing the way. They are simply gone, hidden beneath the waves, unknown and unknowable, unless someone happens to run a sonar survey over them. And sometimes, discovery comes not from searching, but from catastrophe. In 2004, the Indian Ocean tsunami struck the coast of Tamil Nadu with devastating force. Among the thousands of tragedies that occurred that day, something extraordinary was briefly revealed. As the tsunami first withdrew the water from the shore near Mahabalipuram, a UNESCO World Heritage Site, famous for its 7th century rock-cut temples and sculptures, the receding waters exposed stone structures on the seabed that had not been visible in living memory. Witnesses reported seeing the outlines of walls, carved stone blocks, and what appeared to be the remains of ancient structures emerging from the suddenly exposed ocean floor. The sea returned within minutes, covering the structures again. But the glimpse was enough. It confirmed what local fishermen had been saying for generations, that there were temples beneath the waves off Mahabalipuram, remnants of a larger city that the sea had claimed. Subsequent underwater surveys by the Archaeological Survey of India and international teams confirmed the presence of submerged structural remains off the Mahabalipuram coast. Divers found granite blocks with carved decorative elements, remnants of walls, and scattered architectural fragments lying on the seabed at depths of 5 to 8 meters. The finds were consistent with the legends recorded in early European traveller accounts, which described Mahabalipuram as having once been a much larger port city with multiple temples along the waterfront, most of which had been consumed by the sea over the centuries. The tsunami, in its terrible destructive power, had momentarily pulled back the curtain and revealed what was always there, what had always been there, just a few meters beneath the surface, invisible and ignored until catastrophe forced the ocean to give up its secret for a few fleeting minutes. The lesson of Mahabalipuram is the lesson of Dwarka writ small. The evidence is there. It has always been there. It is not hiding in the abyssal depths. It is sitting in shallow coastal waters, often within easy reach of divers, sometimes visible to anyone willing to look over the side of a boat. But we do not look. We walk along beaches and gaze at the horizon without considering what lies just beneath the surface. We build our resorts and our fishing villages and our sacred temples at the water's edge without knowing that the water's edge has been moving steadily and relentlessly for thousands of years, and that what it covered when it advanced, it does not willingly give back. What each of these angles reveals is a different facet of the same truth. The ocean is vast, hostile, poorly understood, and full of surprises. The discovery of hydrothermal vent life shows that our assumptions about what can exist in the ocean are unreliable. The preservation properties of brine pools show that the ocean's effects on submerged objects are varied and unpredictable. The Yonaguni Monument shows that distinguishing natural from artificial in the underwater environment is profoundly difficult. The bizarre creatures of the deep show that the ocean operates by rules we are still discovering. And the difficulty of finding even modern objects in the deep ocean reminds us that the ocean is genuinely capable of erasing things so completely that we never know they were there. Dwarka sits at the intersection of all these themes. It is a real archaeological site, confirmed by decades of investigation, supported by tangible physical evidence, and linked to one of the world's richest literary traditions. And yet it remains incomplete, contested, partially documented, and slowly disappearing. The technology exists to study it more thoroughly. Side-scan sonar, multi-beam bathymetry, photogrammetry, remotely operated vehicles, autonomous underwater vehicles, all of these tools could be brought to bear on the site with transformative results. But resources are limited. Institutional priorities shift. The monsoon seasons closes the window of operability for months at a time, and the political and cultural sensitivities surrounding the site make every decision about how to investigate it fraught with consequence. The math is striking when you look at the global picture. The total area of the world's continental shelves, the zones most likely to contain submerged evidence of ancient human habitation, is approximately 25 million square kilometers. The total area that has been subjected to systematic archaeological survey underwater is a tiny fraction of 1% of that figure. We are not talking about a gap in knowledge. We are talking about a chasm, an abyss as deep and as dark as the ocean itself. The submerged archaeological record of humanity is almost entirely unexplored, and within it, sites like Dwarka are the rare, fortunate exceptions that remind us just how much we are missing. Every expedition to Dwarka has revealed something new. Every new revelation has generated more questions than answers. The city under the sea is not giving up its secrets easily, but the ocean is not waiting for us to finish asking questions. It is advancing its own agenda, the agenda of dissolution, erosion, and silence. The contest between human curiosity and oceanic patience is not one that curiosity can afford to lose. And right now, the ocean is winning. And this is where the answer becomes deeply unsettling. The deeper truth about Dwarka is not about Dwarka, it is about us. It is about what we think we know about the past, and how much of that knowledge rests on the assumption that the most important evidence has survived. It has not. The most important evidence, the evidence of coastal civilizations, maritime cultures, and low-lying settlements from the deep past, is underwater, and we have barely glanced at it. Consider the following. According to scientific estimates, roughly 95% of the world's ocean floor has never been directly observed by human eyes or recorded by high-resolution instruments. The figure is often cited, and it is often met with a kind of reflexive disbelief. Surely, in an age of satellites and sonar and autonomous submarines, we must have mapped more than 5% of the ocean floor in meaningful detail. But the number refers to resolution that would reveal structures the size of the Dwarka ruins. At that level of detail, the figure is not only accurate, it may be generous. Most of the ocean floor is known to us only in the vaguest terms, broad contours derived from satellite gravity measurements that can detect large features like mountain ranges and trenches but cannot resolve individual buildings, walls, or artifacts. The floor of the ocean is mapped at a resolution of roughly 5 kilometers in many areas. That means features smaller than 5 kilometers across are invisible to our best global models. Let that sink in. We live on a planet that is mostly ocean, and we do not know what is on the floor of that ocean, not in any meaningful detail. Not in the way that we know what is on the surface of Mars, which has been mapped at a resolution of roughly 6 meters by the Mars Reconnaissance Orbiter. Not in the way that we know the surface of the Moon, which has been mapped at a resolution of roughly 2 meters by the Lunar Reconnaissance Orbiter. The surfaces of other worlds, worlds that no human has ever visited, are known to us in greater detail than the floor of our own ocean. The irony is so sharp it almost cuts. The technology exists to change this. Autonomous underwater vehicles, equipped with multi-beam sonar and high-resolution cameras, could, in principle, survey the entire ocean floor at archaeological-grade resolution. But the cost would be enormous, estimated by some oceanographers at several $billion. The time required would be measured in decades, and the institutional will to undertake such a project does not currently exist, because the ocean floor, unlike the surface of Mars, does not capture the public imagination in the same way. There is no Dwarka rover beaming back images to a captivated global audience. There is no live stream from the ruins. There is no flag to plant, no footprint to leave, no moment of national triumph to broadcast. The ocean floor is dark, cold, and unforgiving. It does not photograph well. It does not make for good television, and so it remains unmapped, unstudied, and unknown. The Seabed 2030 project, a collaborative initiative launched by the Nippon Foundation and the General Bathymetric Chart of the Oceans, aims to map the entire ocean floor by the end of this decade. It is an ambitious undertaking, and it has made significant progress, drawing together data from research vessels, commercial ships, and autonomous vehicles around the world. But the resolution being targeted is not sufficient for archaeological purposes. The goal is a functional bathymetric map, one that shows the shape of the ocean floor at a scale useful for navigation, fisheries management, and tsunami modeling. It is not an archaeological survey. The features it will resolve, submarine mountains, ridges, canyons, and other large-scale geological formations, are measured in hundreds of meters. The walls of Dwarka, measured in meters or less, would not appear on such a map. To find the drowned cities of the world, we would need a different kind of survey entirely, one conducted at centimeter-level resolution, targeting the shallow continental shelves, where human habitation was most likely. No such survey has been proposed, no budget has been allocated, no institution has taken responsibility. The drowned cities of the world remain, for all practical purposes, invisible to the systems we are building to understand the ocean. More humans have walked on the surface of the moon than have visited the deepest point in the ocean. This is not science fiction. This is a factual statement that bears repeating because it is so counterintuitive. 12 astronauts walked on the moon during the Apollo program between 1969 and 1972. The number of people who have descended to the bottom of the Challenger Deep, the deepest point in the Mariana Trench, remains in the single digits, even including the most recent expeditions. Don Walsh and Jacques Piccard made the first descent in 1960 in the bathyscaphe Trieste. James Cameron made a solo dive in 2012 in the Deep-Sea Challenger. Victor Vescovo made a descent in 2019 in the Limiting Factor. A handful of others have followed. The precise count varies depending on the source, but it remains strikingly, almost absurdly, low. The deepest point on our own planet has been visited by fewer people than the surface of another world. A world that is roughly 384,000 kilometers away. The implications of this for the study of Dwarka and sites like it are profound. If we have not even fully explored the most extreme environments of our own ocean, how can we claim to understand the shallow coastal zones where ancient civilizations most likely flourished? The answer is that we cannot. Our picture of the ancient world is drawn almost entirely from land-based evidence. The cities we know, the monuments we study, the artifacts that fill our museums, all of these come from places that remained above water. The places that went beneath the waves have been, with very few exceptions, ignored, not intentionally, not maliciously, simply because they are difficult to access, expensive to study, and easy to overlook. Something is wrong with our assumptions about the ancient world. We have built our understanding of the human past on the evidence that survived, and we have assumed, implicitly and without much examination, that the evidence that survived is representative of the whole. This is called survivorship bias, and it is one of the most pervasive and dangerous errors in human reasoning. We see the things that made it through the filter. We do not see the things that did not, and we mistake the surviving sample for the complete picture. In the context of archaeology, the filter is the ocean. Rising seas filtered out the coastal civilizations. What remained above water was studied. What went beneath was forgotten. And our understanding of the past was shaped not by the full range of human achievement, but by the fraction that happened to be built on ground that stayed dry. The continental shelves that were exposed during periods of lower sea level were not narrow strips of marginal land. They were vast plains, in some regions extending hundreds of kilometers beyond the current shoreline. The Sunda Shelf in Southeast Asia was a continuous landmass connecting what are now the islands of Indonesia, Malaysia, and mainland Southeast Asia. It covered an area comparable to modern India. It was inundated as sea levels rose, and with it went any evidence of human habitation that may have existed there. We know, from genetic and linguistic evidence, that humans have lived in Southeast Asia for tens of thousands of years. We know, from archaeological evidence on the surviving islands, that these populations were skilled seafarers and toolmakers. But the coastal settlements where they most likely concentrated are now beneath the waves. The Sunda Shelf is silent. Consider Thonis Heraklion, a city that may be the most instructive parallel to Dwarka in the entire catalogue of submerged archaeology. For over 1,000 years, the only evidence that Thonis Heraklion had ever existed was a scattering of references in ancient Greek and Egyptian texts. Herodotus mentioned it. Strabo described it. The Decree of Canopus, carved in stone in the 3rd century before the Common Era, referred to the city as an important port at the mouth of the Nile, but no one could find it. The coastline of Egypt had changed so dramatically since antiquity due to the shifting channels of the Nile Delta and the gradual subsidence of the land that the city's location had been lost. For centuries, scholars debated whether Thonis Heraklion was real or legendary. Some argued it was a literary invention. Others suggested it had been confused with Alexandria. The city existed in a kind of scholarly limbo, too well attested to be dismissed entirely, too thoroughly vanished to be treated as fact. And then, in 2000, the French underwater archaeologist Franck Godillot found it. Using side-scan sonar and systematic survey techniques, Godillot and his team located the remains of Thonis Herakleion in Abu Qir Bay, roughly 6.5 kilometers off the modern Egyptian coastline, under approximately 10 meters of water. What they found was astonishing. An entire city, temples, harbors, canals, colossal statues of pharaohs and gods, some standing over 5 meters tall, lying on the seabed where they had fallen when the ground beneath them liquefied and sank. Ships, dozens of ancient vessels, some still loaded with cargo, gold coins, bronze ritual implements, stels inscribed with hieroglyphics, jewelry, anchors, and the infrastructure of a major international port, a city that had served for centuries as the gateway to Egypt, the place where goods and people from the entire Mediterranean world passed through on their way to the interior of one of the greatest civilizations the world has ever known. The discovery of Thonis Herakleion changed everything. It proved, beyond any reasonable doubt, that major cities could be lost beneath the sea for millennia and then recovered. It proved that ancient literary sources, even when they could not be corroborated by surface archaeology, sometimes described real places with real histories, and it proved that the technology to find and study submerged cities existed, if the funding and the will to use it could be assembled. The parallels with Dwarka are impossible to ignore. Both cities were described in ancient texts. Both were dismissed or doubted by scholars who could not locate them above water. Both were eventually found beneath the waves, confirming the literary tradition in broad outline while revealing complexities that the texts had not anticipated. Both are still being studied, and both raise the same uncomfortable question. How many more are out there? The answer, based on what we know about post-glacial sea level rise and the extent of the world's continental shelves, is potentially hundreds, perhaps thousands. Every coastline that has advanced seaward during periods of lower sea level has subsequently retreated as the ice melted, and with that retreat, any coastal settlements were inundated. The Mediterranean coast, the Arabian Sea coast, the coasts of Southeast Asia, the Atlantic seaboard of Europe, the Gulf Coast of North America. Each of these regions has experienced significant changes in sea level over the past 20,000 years, and each potentially conceals the remains of communities that once stood on dry land. We know of a few, we have found a handful, but the systematic survey that would be necessary to identify them all has never been conducted, and at the current rate of progress, it will not be conducted within our lifetimes. The Dogger Bank in the North Sea, now a shallow sandbank, was once a hilly landscape with rivers, forests, and freshwater lakes. Fishing trawlers in the North Sea have pulled up the bones of mammoths and the stone tools of ancient hunters from the seabed, tantalizing fragments of a submerged world that researchers call Doggerland. In 2019, a team from the University of Bradford published a detailed reconstruction of the Doggerland landscape, based on seismic survey data collected by oil companies. The reconstruction revealed a complex terrain of hills, valleys, marshes, and a large lake system, as by any measure a landscape would have supported significant human, and it is now under 60 meters of North Sea water. Along the western coast of India, the continental shelf extends outward from the modern shoreline, and upon it sits Dwarka, the city that the ancient text remembered and the ocean tried to forget. But Dwarka is not the only site on the Indian continental shelf. The Gulf of Cambay findings, mentioned earlier, detected large geometric features on the seabed at depths of around 30 to 40 meters. The features were interpreted by some researchers as the remains of a very large settlement. Artifacts dredged from the area included pottery fragments, stone tools, and the piece of wood that yielded the controversial radiocarbon date of over 9,000 years before the present. If the site is what some researchers believe it to be, It would predate the earliest known urban settlements in the Indian subcontinent by thousands of years. But the controversy surrounding the Gulf of Cambay site is intense and unresolved. Critics have pointed out that the sonar images are ambiguous, that the dredged artifacts cannot be reliably associated with the seabed features, and that the radiocarbon date of the wood sample may be unreliable due to contamination or displacement from its original context. These criticisms are valid. They reflect the genuine difficulty of doing archaeology in an environment where the normal rules of stratigraphic analysis do not apply. But they also reflect a deeper problem, a problem of institutional skepticism that sometimes hardens into reflex. The archaeological establishment has historically been reluctant to take underwater sites seriously as evidence of urban civilization. Funding for underwater archaeology is a fraction of what is available for land-based excavation. The number of trained maritime archaeologists is tiny compared to the number of their terrestrial colleagues. The infrastructure for underwater investigation, research vessels, diving equipment, sonar systems, remotely operated vehicles is expensive to acquire and maintain. It is simply easier, faster and cheaper to dig on land, and so the land gets dug and the sea remains ignored. Let that sink in. We have organized our entire framework for understanding the human past around the evidence that happens to be above water. We have built universities, departments, funding structures, and career paths around the study of terrestrial sites. And in doing so, we have systematically neglected the vast archive of human activity that lies beneath the ocean surface. This is not a conspiracy. It is not a cover-up. It is the perfectly natural result of practical constraints. People study what they can reach. They study what their institutions fund. They study what their training prepared them for. And for most of archaeology's history, that has meant dry land. The deeper truth, the truth that Dwarka forces us to confront, is that our understanding of the past is shaped as much by where we look as by what we find. And we have been looking in the wrong places. Not entirely wrong. The great riverine civilizations of the ancient world deserve every bit of the scholarly attention they have received. But they represent the survivors, the civilizations that happened to be built on land that remained above water. The civilizations that were built along coastlines that are now submerged have been erased from the conventional record, not by conquest, not by plague, not by any human agency, by the ocean itself, the greatest destroyer of evidence in the history of the planet. This is what makes Dwarka so important, not as a single site, not as proof or disproof of any particular mythological narrative, but as a demonstration that the ocean contains real, tangible, datable evidence of human civilizations that are absent from the conventional archaeological record. Evidence that is slipping away with every passing year, every monsoon, every tidal cycle. Evidence that could reshape our understanding of when and where complex societies first emerged, how they interacted, and how they were ultimately destroyed or transformed by changes in the environment. The ruins beneath the Arabian Sea are whispering. They are telling us that the human story is bigger, older, and more connected to the sea than we ever imagined. They are telling us that the ancient texts, however embellished and mythologized, sometimes contain kernels of genuine historical memory that can survive across astonishing spans of time. And they are telling us that if we do not act, if we do not invest the resources necessary to systematically survey the world's shallow coastal waters, we will lose this evidence forever. The ocean is patient, but it is not idle. It is working day and night, tide by tide, to complete the erasure that it began thousands of years ago. The technology to prevent this loss exists. Multi-beam sonar systems can map the seabed at centimeter-level resolution. Photogrammetry can create detailed three-dimensional digital models of submerged structures. Remotely operated vehicles can survey sites that are too deep or too dangerous for human divers. Autonomous underwater vehicles can cover large areas systematically, tirelessly, and without the limitations of air supply and decompression. The tools are there. What is lacking is the commitment. What is lacking is the funding. What is lacking is the recognition that the floor of the ocean is as important a repository of human heritage as any library, any museum, any archaeological site on dry land. There is an irony here that deserves attention. Humanity spends billions of dollars each year on space exploration, missions to Mars, to the moons of Jupiter and Saturn, to asteroids and comets, to the farthest reaches of the solar system. These missions are worthwhile. They expand our understanding of the universe and push the boundaries of engineering and science. But the exploration of our own ocean floor receives a fraction of the funding, a fraction of the public attention, and a fraction of the political support. We are, in effect, searching the sky for answers while ignoring the archive beneath our feet. We are reaching for other worlds while the record of our own world dissolves in salt water. Dwarka is a case study in this imbalance. Here is a site of genuine archaeological significance, linked to one of the world's most ancient literary traditions, located in waters shallow enough to be accessible to standard diving operations, and yet it remains incompletely documented after decades of intermittent investigation. The work that has been done is heroic, conducted by dedicated researchers, often operating with minimal funding and outdated equipment. But it is not enough. The site is too large, the conditions too challenging, and the questions too important for the current level of effort to be adequate. This is not science fiction. This is the current state of underwater archaeology, a field that has the potential to transform our understanding of the human past, operating on budgets that would not fund a single month of a major space mission, a field that is racing against the clock of oceanic erosion, trying to document evidence that is disappearing in real time, a field that needs not incremental improvement but a fundamental shift in scale, in ambition, and in public support. What does Dwarka mean for humanity? The question seems too large for a single drowned city off the coast of Gujarat. But Dwarka is not a single drowned city. It is a symbol, a symptom, a single visible point in what may be a vast invisible pattern. And the pattern, if it is real, has implications that extend far beyond archaeology, far beyond India, far beyond the study of the past. The first implication is about humility. We have constructed, over the past few centuries, a detailed and confident narrative of human civilization. It begins with small, scattered bands of people. It progresses through the development of agriculture and the domestication of animals. It culminates in the rise of the great riverine civilizations, Sumer, Egypt, the Indus Valley, China, and marches forward through classical antiquity, the medieval period, the Renaissance, the Industrial Revolution, and into the modern era. This narrative is supported by an enormous body of evidence. It is not wrong, but it may be incomplete in ways that are more profound than we have generally acknowledged. And the Dwarka, along with other submerged sites from Doggerland to the Sunda Shelf, suggests that the missing chapters are not trivial addenda. They may be central to the story. If significant coastal civilizations existed during periods of lower sea level, and if those civilizations were inundated by rising seas, then the conventional narrative of human development may be missing entire populations, entire trade networks, entire traditions of engineering, art, and governance. We would not necessarily expect these missing civilizations to have been more advanced than the ones we know. The fantasy of a lost super-civilization, an Atlantis of impossible technology, is not supported by any credible evidence and creates more confusion than clarity. But the missing civilizations may have been different. They may have developed maritime traditions, coastal engineering techniques, and seafaring capabilities that influenced the civilizations that followed them. They may have been the seed beds from which the known civilizations grew. The people who eventually built Mohenjo-Daro and Harappa may have carried with them memories and skills learned at coastal settlements that are now beneath the Arabian Sea. We do not know, and because those settlements are underwater, we may never know. But the possibility is there, and Dwarka gives it weight. The second implication is about vulnerability. The submergence of Dwarka was not, in all likelihood, a sudden catastrophe. The texts describe a dramatic inundation, and there may have been episodes of rapid sea level rise that felt catastrophic to the people who experienced them. But viewed on a geological timescale, the process was most likely gradual. Sea levels rose, coastlines shifted. Settlements that were once safely above the waterline found themselves at the mercy of increasingly frequent flooding. People adapted, rebuilt, retreated inland. Eventually, the ocean won. The city went under. This process is not confined to the ancient past. Sea levels are rising today. The rate of rise has accelerated in recent decades, according to measurements from tide gauges and satellite altimetry. Global mean sea level has risen by roughly 20 centimeters since the beginning of 20th century, and the rate of rise is increasing. Low-lying coastal cities around the world face the prospect of progressive inundation over the coming decades and centuries. Jakarta is sinking. Miami floods with increasing regularity. The island nations of the Pacific watch their shorelines erode year by year. The mechanisms driving modern sea level rise differ from those that submerged ancient Dwarka, but the result is the same. The ocean advances, human settlements retreat, and what cannot retreat is swallowed. There is a strange and melancholy echo between ancient Dwarka and the modern cities that now face similar threats. The people who built Dwarka almost certainly did not understand, in any scientific sense, why the sea was rising. They experienced it, they responded to it. They may have attributed it to divine will or cosmic forces beyond their control, but they could not stop it. And we, with all our scientific understanding, with all our engineering capability, with all our institutional resources, find ourselves in a strikingly similar position. We understand the mechanisms. We can model the projections. We can build seawalls and pump stations and elevated roadways. But the fundamental dynamics are, on the timescales that matter, enormously difficult to reverse. The ocean has always been the larger force. Dwarka is proof. There is a thought experiment that captures the vertigo of this parallel. Imagine an archaeologist, 3,000 years from now, diving in the waters off what once the coast of Florida. The ice sheets have melted further. The coastline has retreated by kilometers. Beneath the waves, this future archaeologist finds the remains of Miami Beach, crumbled concrete towers, rusted steel reinforcement bars, the foundations of hotels and condominiums, their upper stories long since collapsed and scattered by storms, shards of glass, barely recognizable, smoothed by millennia of wave action, fragments of ceramic tile, their original patterns faded but still faintly visible, and everywhere the plastic, vast quantities of it, barely degraded, the most durable artifact of our civilization, persisting in the sediment long after everything else has dissolved or corroded beyond recognition. This future archaeologist would face many of the same challenges that confront the researchers at Dwarka today. Identifying the boundaries of the settlement, distinguishing deliberate construction from natural debris, establishing a chronology for structures that have been jumbled and rearranged by decades of submarine erosion, interpreting artifacts stripped of their context, and, perhaps most poignantly, trying to understand the culture that built these things, a culture that knew, as we know, that the sea was rising, and that built at the water's edge anyway, because the water's edge is where we live. It is where we have always lived. It is where the trade routes converge, where the fish are caught, where the breezes cool the air and the views stretch to the horizon. The water's edge is irresistible, and the water's edge is temporary. Dwarka understood this. Or rather, Dwarka demonstrates this, with a clarity that no amount of climate modelling or policy debate can match. The third implication is about memory. The Mahabharata remembers Dwarka. Across however many centuries, however many generations of oral and written transmission, the memory of a drowned city survived. It was transformed by the process of transmission. It was embellished, mythologized, woven into a theological framework that gave it meaning beyond mere geography. But the core memory, a city by the sea that was swallowed by the waves, persisted with enough specificity that when modern researchers went looking, they found something real. This is remarkable. It suggests that the human capacity for preserving information across long periods, even in the absence of modern recording technology, is more robust than we often assume. How many other ancient texts, how many oral traditions, how many mythologies from cultures around the world contain similar memories? Stories of floods, of drowned lands, cities beneath the sea, are found in traditions from every inhabited continent. The most famous is the biblical flood narrative, but versions exist in Mesopotamian, Greek, Indian, Chinese Aboriginal Australian, and indigenous American traditions. among many others. For a long time, scholars treated these stories as independent inventions, cultural universals that reflected common human anxieties about water and destruction, rather than memories of actual events. But the discovery of sites like Dwarka, combined with the geological evidence for dramatic sea level changes over the past tens of thousands of years, has prompted some researchers to reconsider. Perhaps some flood myths are, at their core, distorted memories of real inundation events, not global floods, not waters covering the entire Earth, but local or regional catastrophes, rising seas swallowing coastal communities, rivers flooding their banks, tsunamis striking unprepared shorelines, events so traumatic that they were remembered and retold for hundreds or thousands of years, growing in the telling, accumulating layers of meaning and metaphor, but never entirely losing the kernel of geographical truth at their center. This is speculative. It cannot be proven with the evidence currently available, but it is a possibility that Dwarka makes harder to dismiss, because at Dwarka, the literary tradition and the archaeological evidence converge. The texts say there was a city. The ocean floor says there was a city. The details do not match perfectly. The golden palaces have not been found. The 900,000 mansions are not there. But the broad outlines align. A fortified city, a major port, a planned urban settlement. On the western tip of the Saurashtra Peninsula, beneath the Arabian Sea, the tradition remembered, the ocean confirmed. There is a fourth implication, and it is perhaps the most uncomfortable of all. It is about responsibility. If the world's continental shelves contain the archaeological remains of past civilizations, then those remains constitute a heritage that belongs in some sense to all of humanity. They are not the property of any single nation, though they lie within national territorial waters. They are not the exclusive domain of any single academic discipline, though archaeology and marine science have the most obvious claims. They are a shared inheritance, a record of what our species has been and done, and they are being destroyed by natural processes that we have no power to stop. The question of who is responsible for documenting and preserving this heritage, and who should pay for it, is one that no international framework has adequately addressed. The UNESCO Convention on the Protection of the Underwater Cultural Heritage, adopted in 2001, provides some legal protection for submerged sites, but ratification has been slow and incomplete. Many of the nations with the most significant underwater archaeological resources, including India, have not ratified the convention. Enforcement is difficult in waters that are remote, poorly monitored, and subject to competing claims. Treasure hunters, salvage operators, and trawler fishermen continue to disturb and destroy underwater sites around the world, sometimes deliberately and sometimes inadvertently. The loss is incalculable and irreversible. An artifact torn from its context by a trawl net or a salvage dredge is an artifact stripped of most of its informational value. It becomes a curiosity, an object divorced from the web of relationships, the stratigraphy, the spatial context that would have given it meaning. And the site from which it was torn is damaged in ways that can never be undone. Dwarka itself has not been immune to these pressures. The waters off Gujarat are busy shipping lanes. Fishing boats drag their nets across the seabed. Development along the coast has altered sediment patterns and current flows. The modern temple city of Dwarka, a major Hindu pilgrimage site, has expanded over the centuries, and some of that expansion has occurred directly above the submerged ruins. The relationship between the living city and the dead one is complex and fraught. The living city draws its spiritual authority in part from its connection to the ancient Dwarka of the texts. But the expansion of the living city and the economic activities associated with it sometimes conflicts with the preservation of the physical evidence that links the two. This is not a problem unique to Dwarka. It is a problem that arises wherever sacred sites coincide with archaeological ones, wherever the needs of the living and the testimony of the dead occupy the same contested ground. What does it mean to live on a planet where the record of our own history is being actively erased? Where the evidence of who we were and what we built is dissolving in salt water? Where the greatest archive of human achievement may lie not in any library or museum, but on the floor of an ocean that we have barely explored? These are not comfortable questions. They do not have comfortable answers. But they are the questions that Dwarka forces us to ask. And in asking them, we begin to understand not just what was lost beneath the waves off Gujarat, but what it means to build on a coastline, to depend on the sea, and to trust, as all coastal peoples must, that the water will not rise too far, too fast, too soon. The ruins beneath the Arabian Sea are not just archaeological curiosities. They are a mirror. They reflect back to us our own fragility, our own impermanence, our own dependence on a thin strip of dry land at the edge of an ocean that has always been larger, deeper, and more powerful than anything we have built. The people of Dwarka built their city at the edge of the sea because the sea gave them life. It gave them food, trade routes, transportation, connection to the wider world. And then it took everything back. We stand in the same position today. Our greatest cities cluster along coastlines. Our global economy depends on maritime trade. Our food supply is linked to the ocean's productivity. We are, in the most fundamental sense, a coastal species. And the coast, as Dwarka reminds us with devastating simplicity, is not permanent. It is a boundary, a shifting, negotiable, ultimately temporary boundary between the world we inhabit and the world of water that surrounds it on every side. There is a city beneath the Arabian Sea. It has been there for a very long time. Longer than any modern nation, longer than any living language, longer than any institution that currently exists on the surface of this planet. It sits on the seabed in the muted half-light of shallow coastal water, its walls worn smooth by millennia of tidal flow, its streets buried under layers of silt and marine sediment, its stories dissolved into the salt. Dwarka, in itself, has become a kind of incantation in the world of underwater archaeology, not because it is the largest submerged site or the oldest or the most thoroughly documented, but because it is the site that proves the principle. It proves that the ancient texts, for all their embellishment and mythologization, sometimes carry within them a kernel of geographical and historical truth that can survive across immense spans of time. It proves that the ocean, for all its destructive power, does not always win completely. Fragments survive, traces endure. The stone remembers what the water tries to forget. We began tonight with a question. What lies beneath the waves off the coast of Gujarat? The answer, as it turns out, is not simple. What lies beneath those waves is a city, yes, but it is also a mirror that reflects back to us our own assumptions about the past, our own ignorance of the ocean, our own vulnerability to the slow, relentless forces of geological change. The ruins of Dwarka do not merely tell us about a civilization that lived and died at the edge of the sea. They tell us about ourselves, about our tendency to forget, about our capacity to rediscover, about the strange, stubborn persistence of memory and stone. The ocean covers 71% of this planet. Within its waters lie answers to questions we have not yet thought to ask. The continental shelves of the world, those shallow margins where land slopes gently into the deep, are an unread library. Dwarka is one page of that library, a page that we have begun to read, haltingly, imperfectly, with tools that are only now becoming adequate to the task. How many more pages are there? How many more cities, harbours, roads and temples lie beneath the waves, waiting for the sonar beam, the diver's lamp, the camera's lens? We do not know. That is the honest answer. We do not know because we have not looked. And we have not looked because the ocean is hard and expensive and dark and indifferent to our curiosity. But the evidence is there. It has always been there. Beneath the tidal surges of the Gulf of Kutch, beneath the gentle swells of the Arabian Sea, beneath the turbid, current-swept waters where the Gomti River meets the salt. The people of ancient Dwarka built something remarkable. They built a city at the meeting point of land and sea, a city of stone walls and planned streets and bustling wharves. They built it knowing, as all coastal peoples know in their bones, that the sea is both provider and destroyer. They built it anyway, and when the sea came for it, as it always does, as it always will, they carried what they could and moved inland, leaving behind the bones of their civilization for the water to claim. Those bones are still there, covered in coral, crusted with barnacles, slowly dissolving in the salt, but still there, still holding the shape of streets that were once walked by living people, still bearing the marks of hands that lifted stone and carved channels and set anchors in the harbour mud. The ocean has been patient. It has had centuries, perhaps millennia, to do its work. But it has not finished. Not yet. Not entirely. Something of Dwarka remains. Something that sonar can detect. Something that divers can touch. Something that cameras can record. For now. And so the race continues. On one side, the ocean, with its infinite patience and its endless motion, grinding the ruins down atom by atom, grain by grain. On the other side, a small number of dedicated researchers, working with limited funds and imperfect tools, trying to document what remains before it is gone. It is not an equal contest. The ocean has all the time in the world. The researchers do not. Every season brings new erosion, new sediment burial, new loss. The city is fading, slowly, silently, stone by stone. But this is the nature of the work. This is the nature of all work that matters. To struggle against impermanence. To record what is passing. To hold up a lamp in the darkness and say, this was here. This existed. This mattered. The ruins of Dwarka are a testament not only to the people who built the city, but to the people who found it, who studied it, who fought against the bureaucratic and environmental obstacles to bring its existence to light. They are a testament to the stubborn human conviction that the past deserves to be known, even when the past is buried under 40 feet of seawater and 10,000 years of silence. The Mahabharata tells us that when Dwarka sank, the survivors watched from the shore as the ocean consumed their home. They watched the waves close over the walls. They watched the towers disappear beneath the surface. They watched until there was nothing left to see but the flat, unbroken line of the sea. And then they turned inland and walked away, carrying their stories with them. Those stories survived. Against all odds, across all the centuries, through all the transformations of language and culture and belief, the story of the drowned city endured. And now, beneath the waves, the city itself has been found. Not the golden palaces of legend, not the 1,000 shining domes of myth, but something real, something tangible, something made of stone and silt and silence. It is there still, beneath the water, in the dark, waiting, and the ocean, as it has always done, keeps its secrets close. But perhaps that is not the right way to end this story. Because secrets imply concealment, and the ocean is not concealing anything. It is simply vast. It is simply indifferent. It does not care about our questions. It does not care about our timelines, our funding cycles, our academic careers, our national debates about whose history matters and whose does not. It simply is. It has been here longer than any civilization. It will be here long after the last civilization has fallen. It was here before Dwarka was built, and it was here when Dwarka went under, and it will be here when the last stone of Dwarka's walls has dissolved into sediment and been carried out to the deep ocean by currents that have no name and no memory. And yet we keep looking. We keep sending divers down into the murk. We keep towing sonar arrays through turbid water. We keep writing grant proposals and calibrating instruments and arguing about dates. We keep doing this because the alternative of simply accepting that the past is lost, that the ocean has won, that there is nothing to be done, is intolerable to something deep and essential in the human character. We are a species that remembers. We are a species that digs. We are a species that, when told something has been lost forever, picks up a shovel or a sonar transducer or a diving mask and says, "Let me look. That impulse is what brought SR Rao to the waters off Bet Dwarka in the early 1980s. It is what keeps researchers returning to those waters today, year after year, monsoon after monsoon. It is what drives the slow, painstaking, underfunded work of underwater archaeology in every ocean and every sea on this planet. It is not glamorous work. It is not well-paid work. It is often uncomfortable, sometimes dangerous, and always uncertain. But it is necessary work, because the alternative is silence. And the human species, for all its many flaws, has never been very good at silence. There is a word in Sanskrit, smriti, which means memory, or that which is remembered. It is used to describe a category of sacred texts, texts that are considered to be the product of human memory rather than divine revelation. The Mahabharata is classified as Sriti. The Puranas are classified as Smriti. They are the remembered things, and within them, woven into the fabric of poetry and theology and moral instruction, is the memory of a city by the sea, a city that the ocean claimed, a city that the tradition kept alive, a city that the divers found. Smriti, memory, the thing that survives when everything else dissolves. The ruins of Dwarka are Sriti made stone. They are memory in its most physical form, memory that can be touched, measured, photographed, and dated. Memory that is slowly, inevitably, returning to the sea from which it was drawn. Memory that has perhaps a few more centuries, perhaps a few more decades, before the last legible trace is gone, and all that remains is the text, the words on the page. The story told and retold, the tradition carried forward by people who have never seen the ruins and never will, but who remember because memory is what humans do. Somewhere beneath the waves off Gujarat, a wall still stands. It has been standing for a very long time. Barnacles grow on its surface, fish shelter in its crevices, silt accumulates in its corners. The current pushes against it, gently, constantly, the way the current has pushed for centuries. The wall does not resist. It cannot. It is stone, and stone is patient, but stone is not eternal. Nothing is eternal except the ocean itself, and even that claim is probably too bold by half. But for now, for this moment, for this brief flicker of geological time, in which we happen to be alive and curious and stubborn enough to look, the wall is there, Dwarka is there, the evidence is there, beneath the water, in the dark, telling anyone who will listen the story of a city that was built and loved and lost, and found and will one day be lost again. That is the story. Not a story with a clean ending, not a story with a resolution, but a real story, a human story. A story about what we build at the edge of the water, and what the water eventually takes, and what, against all odds, we manage to remember. And the ocean, as it has always done, keeps its secrets close. But not all of them, not yet, not quite.